In this video, we're going to be looking at the first part of simplifying surds, where we break them down. Now, why simplify surds? Well, before we answer that question, we kind of need to remind ourselves about what a surd is. So your surd is the square root of a number that basically doesn't have a nice answer. The formal term for that is it's an irrational answer or an irrational number, and it is a decimal that goes on and on forever, but doesn't have any form of pattern to it. It's always changing in an ongoing and unpredictable way. That number is not useful to have written down, which is why we can leave things in surd form, because it's just easier to do it and easier to do sums with, rather than have a long decimal that goes on forever. So what can happen is that whilst surds are a better way of writing a decimal, you can have some surds that can be written even nicer, in the same way that you can break down a fraction. So 3 over 6 is the same as 1 over 2, but we'll all agree that 1 over 2 is definitely a nicer, simpler looking fraction. Well, the same can be said for things like root 8. So your calculator does this automatically. When you type in a surd into your calculator, if it can be simplified, your calculator will do it. So 2 examples here, root 8 and root 27, can be simplified to give you 2 root 2 and 3 root 3. So how does this happen? Well, it just so happens that there is a formula, and it's technically in one of your law of indices, where if you have a multiple to a power, you can write them as the multiple of the powers separately. Well, a power is just, a root is just a power that's a fractional power. So technically from this, we can get that if you have a surd or a root that is of a multiple, you can split them up into separate pieces. Now, while that might not be useful for something like root 2, because 2 can only be written as 2 times 1, so there's not really any benefit to doing that, you can have other surds, for example, 8, root 8, where the 8 can be broken up into 2 factors, one of which has a nice square root. So whilst root 8 is still a surd, a bit of it or a factor of it can be changed so that it doesn't be a part of the surd anymore. So when we have root 4 times root 2, we can then write it like this, and then that root 4 turns into a whole number 2, and suddenly we end up with 2 root 2, which is technically simpler than root 8. It might have the appearance of, because you're writing more stuff, there's less to write here compared to that. But if you imagine doing any form of sums, having the number 2 written down twice, one on the outside and one in the surd, is an easier number to deal with than 8. It's my best way of describing why it's simpler. If you had to do surd problems without a calculator, you'll soon realize that simplifying will help you, for example, in the multiplying in the next video. Another example, root 27. Root 27 can be broken down as root 9 times root 3, and then that 9 on the outside, or that root 9 beforehand, can then turn into 3. So surds can be simplified if you can divide by a number that has a nice square root, or in other words, any of the square numbers. So with the examples we're about to look at, any of these numbers, if you can divide by them, then your surd can be simplified. Now, you don't have to technically remember all of these numbers in terms of division. The key ones that you want to look for actually are 4, 9, 25, and 49. 100 is kind of nice too, because if you have a number that's got 2 zeros in the end, then it's obvious that it can be divided by 100. But 4, 9, 25, and 49 are the main ones that we're going to look at here. Whilst you can, of course, if you spot that something can be divided by 16 or 36, that's totally fine. You can go ahead and do it. But the equivalent analogy would be that if you had a fraction that was, say, 25 over 125, okay? Sure, you maybe know that top and bottom can be divided by 25, but let's say you didn't. Let's just say you knew straight away top and bottom can be divided by 5, then that would turn into that as your fraction, and then you would simplify it again, top and bottom, divide by 5 again, and we end up with a fifth. So you've kind of got this middle step. When you simplify fractions as an option, you have the same idea with surds, and you're going to see that just now. So root 12, for example, I'll start with. 12, can it be divided by 4? Yes, so that's what I'm going to split this up as. A root 4, and then what's left over is a root 3. That root 4 then turns into a 2, and you have 2 lots of root 3 is your fully simplified surd there. Root 32 next. Can I divide it by 4? Yes, so I would. Root 4, I will be left with 8. That root 4 then becomes a 2 root 8. And now I'm going to look at this number on the inside. Can 8 be divided by 4? Yes. So I'm going to break that up as a root 4 times root 2 with the 2 on the front. That root 4 in the middle then turns into a 2 of its own with a root 2 in the end. And we have this other 2 out at the front. Now, bearing in mind that everything that's been going on here so far involves multiplying, so even though you don't see it written down, that's not a 2 beside a 2 for a 22. It's a 2 multiplied by that root 4, therefore it's a 2 times root 2, which gives us an answer of 4 root 2. Now, you might be saying, well, I knew that this could be divided by 16, so why didn't you just do that? Truth is, you can. So if you know that 16 goes into 32, then you can write it like this straight away, root 16 times root 2, and then you end up with 4 root 2. But the main reason why I want to show you what I did there is because that's the sort of safer or first approach you should look at when simplifying a surd. Can it be divided by 4? Can it be divided by 9? Can it be divided by 25? If you happen to spot a quicker way of doing it with a bigger factor, then by all means go for it. But if you take it one step at a time, then you're always going to get there at the end, in this case 4 root 2. Next one, you might have a surd that already has a number out front. Nothing changes there. We're looking at what 8 can be divided by that has a nice square root. So again, we have a root 4 times root 2 giving us a 2 root 2. But of course, we've still got that 3 at the front, which will then multiply with our 2 to give our final answer of 6 root 2. And then lastly, root 720. Well, if any of you knew how to simplify this surd in one go, then fair play. If not, let's just take it one step at a time. So I know that 9 goes into 72, so 9 will definitely go into 720. So let's rewrite this as root 9 times root 80, giving us 3 root 80. Then, next step, I'm going to be like, well, 80, I know that can be divided by 4, so we end up with 3 root 4 times root 20. Should put a multiple in there as well, which becomes a 3 times 2 root 20, which becomes a 6 root 20. And don't get me wrong, if you're happy enough to take this step, jumping from this step here to there, that's fine. I'm just showing all of the steps here for this example. Next step, I know that 20 can be divided by 4, so I can rewrite it as root 4 times root 5. That root 4 is then going to mix with that 6 when it becomes a 2, giving us 12 root 5, and then that 5 in the root can't be divided by anything, so that is our fully simplified surd. Now, if you had turned around and said, well, I actually know that 720 can be divided by 144, and you chose to write it like this, then fair enough. As long as you show that middle step in your simplifying process, then however many steps you take, it's entirely up to yourself. Done.